In last lecture we discussed properties of inverse trigonometric functions, and we also see how to remember that properties, and we also see table for principal branch value. So on that properties we see problems from exercise 3.3. So the first question is, find the principal values of following. So we have to take first question, sin inverse 1 by 2. Now see the first question, sin inverse of 1 by 2. So we first see the principal value branch for this sin inverse. So we denote this as, let sin inverse of 1 by 2 is equals to alpha. Therefore the principal value branch of sin inverse x is minus pi by 2 to pi by 2. Close interval minus pi by 2 to pi by 2. So the value which we are going to find must belong to this close interval minus pi by 2 to plus pi by 2. So we consider sin inverse 1 by 2 equals to alpha. From this we write sin alpha is equals to 1 by 2 from this. So we have to find for which angle we get 1 by 2. We know that sin 30 is 1 by 2, that is sin pi by 6 is 1 by 2. So we write here sin pi by 6 is equals to 1 by 2. So from this we write alpha is equals to pi by 6. Now we have to check whether this alpha equals to pi by 6 belonging to this closed interval or not. You can easily check. Minus pi by 2 means minus 90. This pi by 2 means plus 90. And we know that 30 lies between minus 90 and plus 19. Therefore we write, therefore minus pi by 2 less or equals to alpha less or equals to pi by. You can also write in this way also for your convenience. Here is 0, 30, 45, 60 plus 90. Here minus 30, minus 45, minus 60, minus 90. If you write in radian form, pi by 6, pi by 4, here pi by 3, pi by 2, here minus pi by 6, then minus pi by 4, minus pi by 3 and minus pi by 2. Now you can check this pi by 6 belongs to this interval. So from this we say alpha equals to pi by 6 is the solution of this equation. Now second example, cosec inverse of 2. We have to find the principal value. Now we first write principal value branch of cosec inverse x. Therefore the principal value branch of cosec inverse x is minus pi by 2 to plus pi by 2 minus 0 is the principal value branch for the cosec inverse x. Therefore let cosec inverse 2 is equal to alpha. That means this alpha must belong to this closed interval and alpha not equals to 0. Therefore cosec alpha is equals to 2. Therefore we know for angle 30, that is for pi by 6, cosec is 2. Therefore cosec alpha is equals to cosec pi by 6 is equals to 2. Therefore alpha is equals to pi by 6, and this alpha belongs to this minus pi by 2 less or equals to alpha less or equals to pi by 2, and alpha not equals to 0. So this condition is satisfied. Therefore alpha equals to pi by 6 is the principal value for this given cosec inverse 2. Now see the third example. We have to find the principal value of tan inverse of minus 1. So we write first principal value branch of tan inverse x is open interval minus pi by 2 to plus pi by 2. So we have to find the value which lies between minus 90 and plus 90. So we write here, let tan inverse of minus 1 is equals to alpha. Therefore tan alpha is equals to minus 1. Now we first consider for which angle value is 1. So we write here tan pi by 4 because tan 45 is 1. So by using the property we write tan of minus theta equals to minus tan theta. So we write here tan of minus pi by 4, you can write reason here, tan of minus theta equals to minus tan theta. So we write here minus tan theta in terms of tan of minus theta. Therefore tan alpha is equals to, from this we write tan alpha equals to tan of minus pi by 4, that is equals to alpha, that is equals to, we have considered this value equals to minus 1. Therefore alpha is equals to, if we compare this we get alpha equals to minus pi by 4. Now we have to check whether this minus pi by 4, that is minus 45, belonging to this interval or not. You can manually check. Here is 0, here plus 45 plus 90, here minus 45 minus 90. That means this minus 44 lies between minus 90 and plus 90. So this belongs to, therefore minus pi by 2 less than alpha less than pi by 2. Therefore alpha equals to minus pi by 4 is the principal value for tan inverse of minus 1. Now see the problem number 4, tan inverse of minus root 3. This problem also we solve by taking the reference of previous example. So we write here the principal value branch of tan inverse is minus pi by 2 plus pi by 2. So we take tan inverse of minus root 3 equals to alpha. Therefore tan alpha equals to minus root 3. We know that tan pi by 3 is root 3. So again using the formula tan of minus theta equals to minus tan theta. So we write here tan of minus pi by 3. Now pi by 3, that is 60. So again we draw a rough sketch here, 45, 60, 90. Minus 45, 60, 90. So from this we conclude that this minus 60 belongs to this closed interval minus 90 plus 90. So therefore tan alpha is equals to tan minus pi by 3 is equals to this minus root 3. Therefore alpha is equals to minus pi by 3 and minus pi by 2 less than alpha less than plus pi by 2. Therefore alpha equals to minus pi by 3 is the principal value of tan inverse minus root 3. Now see the next example, sin inverse of 1 by root 2. So here function is sin inverse. So the principal value branch of sin inverse x is closed interval minus pi by 2 plus pi by 2. Therefore we consider sin inverse of 1 by 2, 1 by root 2 is equals to alpha. Therefore sin alpha is equals to 1 by root 2. So for sin 45 we get 1 by root 2. So we write here sin pi by 4. Therefore alpha is equals to pi by 4. Now we have to check whether this pi by 4 belonging to this closed interval or not. We know that 45 lies between minus 90 and plus 19 and minus pi by 2 less than alpha less or equals to alpha less or equals to plus pi by 2. Therefore alpha is equals to pi by 4 is the principal value of sin inverse 1 by root 2. Therefore alpha is equals to pi by 4 is the principal value of sin inverse 1 by root 2. Now see the next example, cos inverse of minus 1 by 2. So we have to see principal value branch for cos inverse. Therefore the principal value branch of cos inverse x is closed interval 0 pi. So we consider cos inverse of minus 1 by 2 is equal to alpha. That cos inverse minus 1 by 2 equals to alpha. Therefore cos alpha is equals to minus 1 by 2. So we have to find first for which angle we get 1 by 2 for cos. We know that cos 60 is 1 by 2, that we write as pi by 3 here. Now we cannot write this as cos of minus theta because cos of minus theta equals to plus cos theta. So we have to use the up down formula, that is cos of pi minus theta is equals to minus cos theta. So instead of theta here value is pi by 3. So cos of pi minus pi by 3 equals to minus cos pi by 3. So from this we write 3 pi, that is cos 2 pi by 3. Which formula we use here? Cos of pi minus theta is equal to minus cos theta. In this problem, in place of theta we have pi by 3. So we directly replace this minus cos pi by 3 by cos 2 pi by 3. So cos alpha equals to cos 2 pi by 3. Cos alpha is equals to cos 2 pi by 3. Therefore alpha is equals to 2 pi by 3. Pi by 3 means 60. 16 to the 120. So 120 belongs to this closed interval 0 pi. And this 0 less or equals to alpha less or equals to pi. Therefore alpha is equals to 2 pi by 3 is the principal value of cos inverse minus 1 by 2. In this way we can solve problems on principal value. The question number 2, evaluate the following. First, tan inverse 1 plus cos inverse 1 by 2 plus sin inverse 1 by 2. In previous example, we find single quantity ratios Here we have to find tan inverse first, cos inverse of 1 by 2, then sin inverse of 1 by 2, then we have to add all these values. So we see one by one. Now see the first example. So we write here in solution, let tan inverse of 1 is equals to alpha. This alpha must belongs to open interval minus pi by 2 to pi by 2, because for tan inverse x principal value branch is open interval minus pi by 2 pi by 2. So the value must between minus 90 and plus 90. So we write here tan inverse of 1 equals to alpha, therefore tan alpha is equals to 1. Tan alpha is equals to tan pi by 4, because tan pi by 4 is 1. So from this we write alpha is equals to pi by 4. And minus pi by 2 strictly less than alpha, strictly less than pi by 2. So we denote as equation number 1. Now we have to consider cos inverse of 1 by 2. So we consider, let cos inverse of 1 by 2 is equals to beta. Therefore we write cos beta is equals to 1 by 2. So we know cos 60 is 1 by 2. So we write here cos beta is equals to cos 60, which we write as pi by 3. So we get here beta is equals to pi by 3. And for cos inverse, interval is close interval 0 pi. Therefore, we write here, and 0 less or equals to beta less or equals to pi. So the second value is beta equals to pi by 3. Now we have to calculate a third value, that is sin inverse of 1 by 2. So we consider, let sin inverse of 1 by 2 is equals to gamma. Therefore sin gamma is equals to 1 by 2. Sin gamma is equals to, we know that sin 30 is 1 by 2. So we write here sin pi by 6 is equals to 1 by 2. Therefore gamma is equals to pi by 6. Now for sin ratio, principal value branch is close interval minus pi by 2 pi by 2, and minus pi by 2 strictly less than or equals to pi. We write here less or equals to gamma less or equals to plus pi by 2. Now all the conditions are satisfied. So we have to substitute. We denote it as equation number 2. This is equation number 3. So from equation 1 to 3, we substitute the value of tan inverse 1, cos inverse 1 by 2, sin inverse 1 by 2. So in final result, we add tan inverse 1, that we replace, that we substitute for tan inverse 1 is alpha and calculated value is pi by 4. So we write here pi by 4. Second value cos inverse of 1 by 2, that is we consider beta, and value of beta is pi by 3. So we substitute pi by 3. And third value sin inverse 1 by 2, which we consider by gamma. So we write here value of gamma, that is pi by 6. Now we have to add these terms. So here we make base same. So for that we multiply and divide by 2. So we get here 2 pi by 6 plus pi by 6, pi by 4 plus, here base is same, 2 pi plus pi, that is 3 pi upon 6. So after adding, first term is pi by 4. After cancelling this, 3 2 are 6. So we get here pi by 2. So multiply and divide by 2. 2 pi upon 2 into 2, that is equals to pi by 4 plus 2 pi plus 4, that is equals to. Now here base is same, so we write base pi plus 2 pi, that is 3 pi. So the value of tan inverse 1 plus cos inverse 1 by 2 plus sin inverse 1 by 2 is equals to 3 pi by 4. In this way we can calculate the value. Now see the example number second, cos inverse of 1 by 2 plus 2 sin inverse 1 by 2. So we first find the value of cos inverse 1 by 2. In solution, let cos inverse of 1 by 2 equals to alpha. Therefore, cos alpha is equals to 1 by 2. So cos 60 is 1 by 2. So we write here cos pi by 3. Therefore, alpha is equals to pi by 3. And for cos, we know the principal branch value branch, that is 0 pi, and 0 less or equals to pi by 3, or in place of pi by 3 we write alpha less than pi. So the first value is pi by 3. Now we have to find the second value, that is for sin inverse 1 by 2. Sin inverse 1 by 2 is equals to beta. Therefore, sin beta is equals to 1 by 2. We know that sin 30 is 1 by 2, so we write here sin pi by 6. Therefore, beta is equals to pi by 6. And for sin minus pi by 2 less than beta less than or equals to pi by 2 is the principal branch value, means this condition is satisfied. So we denote alpha by pi by 3, beta by pi by 6, and after substituting these values, we get here cos inverse of 1 by 2, which we calculate here alpha by pi by 3. So we substitute pi by 3. To sin inverse 1 by 2, sin inverse 1 by 2 we calculate pi by 6 because it is represented by b. So we get here pi by 6. Now after simplifying it, we get pi by 3 plus, that is pi by 3, that is equals to 2 pi by 3. Therefore, the value of given equation is 2 pi by 3.